Right, hello, this is going to be about MazeMaker, and I'll quickly show you what it should look like when you've finished. So you can see what's happening here. This is quite a slowed down version. The purple, they're all purple I suppose, the lighter purple is showing where it is, and you can see a stack growing. Every time we visit a cell, we push it onto the stack, and then when we get stuck, so it's going to go up there and get stuck now. So it doesn't visit cells, so it starts popping the stack. So this is reducing size now. Now eventually we've visited all the cells, so now it just keeps popping the stack, and if it gets to a cell that hasn't been visited, it will visit it because it's trying to look for unvisited cells. Okay, but then it chooses, when it was doing it originally, it was choosing a random one. So this does the size. You can change the size on there. Okay, so at the moment it's just looking for a random unvisited cell that it has. Okay, and then it will keep doing that. And eventually, yeah, it goes on itself. So it'll go up there. No, it didn't. Right. Okay, stuck. No, it wasn't stuck. So it had a choice there. Okay, so it still hasn't popped the stack. Now, no. Okay, so it's fine. So this is quite a big one. So the stack's going to get quite big. Right, anyway, there we go. Right, now the one that you've got is not that one. It's this one, which is the student version. Now, the student version's got the stuff taken out. Now, you can see on this one, it's moving, but it's not showing its current cell, and it's also not removing the walls either. Now, a wall is, so it's looking for, it's going to go and find that cell in a minute, and then it's going to backtrack to where it finished. So that is, you've got to modify that one. Now, so in terms of what we have a list of cell. A cell is a class defined here. I'll talk about that in a minute. And that's called grid. And we've got a stack as well, so we can show the stack. And we've also showed the stack as a load of labels in the flow layout panel. So if I just quickly go to the designer, you can see that that's a picture box where we draw the maze. And this is a flow layout panel here where we just add labels, but they grow from top to bottom like a stack. All right. There's the slider, that's the proper name for that is called. Right, okay, so that's your program that you've got, and it doesn't work fully yet, but you will get it to work. Right, so first thing is we've got our constructor here, so that sets up the paint event argument on the canvas, which you need to do the drawing on there. We do the timer tick event as well. We enable it, and we set the timer to be 400. Okay, so if we go to the timer tick there, I'm going to press F12 to get there. All right, yeah, I am. And then you can see all it does is invalidate. Invalidate just calls the paint event argument. So this paint event argument gets called every 400 milliseconds. Right, then this is about setting up the flow layout panel so it grows from bottom to top. Okay, and we've got the cell width there. That's taken from the TB cell width. Well, I'm trying to remember what TB stands for now. What's that? What's these things called? It's a track bar. Track bar. That's right. Sounds like a cereal bar. Right. Okay. So that is what we've got there. Then on the paint, we've got this. So we got current and next as well. So current and next. So current's our current cell, and our next one is our next one. Okay, and that's defined as cells. Let's have a quick look at cells before we do anything else. Right. So in cells, we're declaring a random. We have a row and a column where we are. Now we'll talk about that in a bit more detail in a minute, whether it's been visited or not. So this is an individual cell. Okay, and a size. So we also have walls as well. So that tells us what walls are visible. So when they're all true to start with, so that's top, right, bottom, left. So that's always remember that order: top, right, bottom, left. They're all true because we're going to draw all 4 boxes, 4 around it. Okay. So if I just quickly go back to here, you can see that so that's top, left, bottom, right. Now you notice 2 cells together will have 2 walls next to each other. So when we clear, so it went from there to there, we'd have to clear this cell's bottom, but this cell's top. Okay, so that's current and that's next. So we'd have to remove the current bottom and the next is top. Okay, that makes sense. All right, okay. So there's our cell. And we have our show method here. Now the show method here is basically saying, right, if we can see if we have a wall at the top, then we draw a line based upon that. Okay, we're using our X and Y coordinates there. Now the X and Y is calculated from the column and the row that we're on and the size of the cell. All right, so that is how we'll know the X and Y coordinates of where we are. All right, so that gives us the top X and Y coordinate there for that cell there. Okay, so it's based upon the width and what the column and the size. Okay, column times the size. So it's pretty straightforward. You can work that out. No, it's not rubbing out. Right. Okay. So, and then we've got this thing called index here. Now, what is that about? Well, let's go back to our cells. So we all know that this one would be 1, 2. This cell down here would be 3, 2. So it goes row, column. Always that way around. Counterintuitive, I know, but that's the way it works. But we're not doing that. We're not. Well, we are, and we're not. Well, actually, what we're doing is we have 0, 1, 2, 3, 4, 5, 6. So it's a list. We have a list of these. So grid is a list, okay, of cells. Okay, so so when we actually go to this element here, let's just choose one at random. So that's 2, 3. What we need to do is convert that into an actual index in the list. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so that's 13. And if you look at the actual code there, that's the code that does it. So it's just row times number of columns plus the column. And that's the method of working that out. So if you basically get from a row and a column to a single index. This is checking our neighbours. Now, this is something new you won't have seen here. This is called the ternary if or operator. I call it an inline if. Now, basically, that's saying cell top is equal to this. Okay. Sorry, if that is not equal to -1, if that is true, then top equals that, else equals null. So it's just a way of writing an if statement in one line. Okay, so just bear that in mind again. So that's the condition there. If that is not equal to -1, then we do the bit after the question mark, which is true. That's the true part, and then the colon indicates the else part. So it's a way of just doing. If you just have one line, one if then else, one line of code in each, then that's a sort of a snazzier way of doing it, if you like. So that's checking your neighbours. So what that is doing is it's got a list of neighbours here. So we're finding out what's the top, right, bottom, and left. Yeah, and if the top is null, in other words, there isn't one at the top. Okay, because we don't want to obviously go off the top, and we haven't visited it, and then we add it to neighbours. So we just make up a list of neighbours here. Okay, and then this one returns a cell from one of these. Okay, so we make up a list. Now the list might only contain one or two or even none because we've already visited them all. Okay, so let's go back to where that's called then. And we're back into here. So check neighbours. So next there. So next may return back null if there are no neighbours. So if we do, what do? We pop the stack and make our current one equal to that. Okay. Ooh, am I in the student one? Yeah, I am. Okay, so I've actually got a bit of label stuff there. That's fine. That's fine. Okay, so that is what it's doing now. If you haven't visited, then we say next.visited equals true. We push it onto the stack. and then this is doing the label stuff here. Okay, I left a lot of it in actually. Now, they've got this function called display stack, which we'll talk about in a minute, and so forth. Notice I've left some blank code in there. Right. That's its remove walls. Right, okay. So at the moment, remove walls isn't actually being called. When you uncomment it out, it will do some. I won't want to go into too much detail now, but that is basically saying you've got X here. So I'm reducing current. So if I've got current here, let's say that's current there, next is there. Okay. And if I reduce the row, I'm going to do this one down here, this one here. So I say current row minus next row. So this is 1 minus 2 equals minus 1. Okay. Now, I've got if it equals 1. So that would be a situation where, let's do that then. So that would be current there, next equals there. And that would be 2 minus 1. Yep, equals 1. So we know if that's the case, then we're going to say, right, current walls 3 is false. So current walls 3. So remember that is 0, 1, 2, 3. So current walls 0. So that's that top wall there. And we should also then do next walls 2. So this is next 0, 1, 2 is false as well, because there's 2 walls there, even though it looks like there's 1. So you have to get rid of both. Otherwise, if you just get rid of the current top wall, you'll still see the next bottom wall. Right, okay. Let's quickly look at the exercise that you've got to do. I think that's enough explanation. Well, you be the judge of that. So that's going to be the link to this video you're watching now. So show the current cell being visited. So it says method in the highlight in the cell class. So the method in the highlight in the cell class, can't speak, the method highlight in the cell class. There you go there. So basically, I've already got that for you. All you need to do is do this fill rectangle. So fill rectangle fills it with a solid color as opposed to draw rectangle, just does the lines. So you're just missing some stuff there. Now, if you're looking for how to do rectangles there's a fill rectangle example there on line 33, right? So that should be fairly straightforward. Remove walls, I kind of already talked about remove walls. So it should be, I kind of gave the game away slightly when I talked about my first part there. Display the stack, the method display stack is not complete. The cell 00 should be the first cell entered and the last cell to leave. It's LIFO, last in, first out. Now, at the moment, then, you've got, what does it say? Display the stack method. Now, display the stack method is on this form here. And it's down the bottom, I think. Come on, Brown, find it. Reset the maze, remove walls, display the stack, right. Okay, so what we've got is I've cleared that already for you. So add the label list to the flow layout panel. Right, so we've got label list has already been sorted out. Now you notice here, when we're adding or drawing, or setting up our next here, so next visited equals true, the stack is push current, the label equals new label, so that's creating a new label. I'm setting up the label back color with the border, and I'm saying current row, and I'm adding it to my list there. So I've got a list there of labels, okay, and then basically I want to show it. You don't need to mess with the stack at all, okay? You just deal with the label list, all right? So display the stack, just mess with label list there, and it should look like, when you've finished, this. So the first cell to go on, 0, 0, and we're adding each one every time we visit a new one. So that's a good one because that's going to get stuck. So then it can't, it starts popping the stack, telling us where to go, and then it's start growing again there. That was a good example. Right, there you go. Nice, easy. I'm not sure if this is Future Forward Day or it's an assignment to do over the holiday or both. Okay, you'll find out. Thank you very much for your time.